Hello everyone. In this video, I'm going to discuss the work on method for image-based radiodensity profilometry to measure remodeling at the bone-callus interface in sheep. Structure remodeling at the bone-callus interface is an important feature of the secondary fracture healing process. Nanoindentation technology was used in previous study to investigate the spatial and temporal mapping of bone structure. The cortical bone increases in porosity and develops a decreasing gradient elastic modulus toward the callus. The purpose of this study was to assess whether radiodensity data from micro-CT scan can be used to non-invasively quantify structural remodeling adaptations at the bone-callus interface in sheep. The imaging comes from a previous study of 26 sheep that have a 3 mm gap tibial osteotomy stabilized with a medial 12-hole stainless steel plate. The region of interest was selected at 3 different locations shown in the figure: proximal, distal, and mid-shaft at both intact and operating limbs. We built a semi-automatic image segmentation tools in my lab to segment out cortical bone and callus. The workflow is shown below. The data was sampled outward from the endosteel surface of the cortical bone. The radiodensity value along the profile lines in the grayscale images was retrieved. We use a product of two sigmoidal functions with a linear term and a constant as the fitting function. Each profile line was reduced to set its linear coordinate system to 0 at the peristeel surface. Negative coordinates were normalized to the local cortex thickness. Positive coordinates were normalized to the double local color thickness or cortical bone thickness if intact. Figure shows profilometry curves sampled at the proximal end and the distal end. Comparing the intact versus operated groups at both distal and proximal end of the bone, we have two findings. First, mean cortical density was significantly lower in operated limbs compared to intact. Second, the slope of the density profile curves at the peristeel surface was significantly reduced in operated limbs compared to intact one. Profilometry curves were also sampled at the midshaft of the intact tibia and the operated tibia. In the operated tibia, the local cortical wall density was decreased compared to the matched intact contralateral tibia, and the positive density gradient disappeared from the cortical region. This data shows that in sheep, significant adaptive changes have occurred in cortical bone bounded by callus by 9 weeks post-operation. To conclude, this study suggests that remodeling is quantifiable using image data only. This measurement may be useful as an indicator of healing speed by establishing the status of fracture on a continuum of mechanical and structural adaptations that arise during healing.